This recording is meant to help you to work through some stoichiometry problems. Okay, so I'm working through the 5.24 multi-step stoichiometry worksheet that is linked as practice. And I did a couple of things before starting this video. The first thing I did was I balanced this equation so that I have all of my coefficients. Remember, from my coefficients, I get my molar ratios. Okay, so I need my coefficients for that. And then below that, all I've done for the map, I know that we have been drawing out these elaborate maps. All that I did was just figure out what the molar mass for each of these was. And how I did that was I looked at my periodic table. I saw how much each of these weighed. So for example, oxygen weighs 16. And then I added up the mass of all of the atoms within the compound. So for example, ammonia here has 1 nitrogen and 3 hydrogens. So 1 nitrogen is 14.01. Each hydrogen is 1.008, and I just add all those together. Okay. All right. So I'm just going to go through a couple of different examples. So the first one, first thing I always do is I start off by writing what I've been given. So here I've been given 15.6 grams of solid sodium cyanide. And it's super important that you are writing down all of the labels here, okay? If you are in NAMO's class, you did fractions with little multiplication symbols in between them. I always draw this just out as boxes and not fractions, but it's exactly the same thing. Okay, so grams of calcium cyanide is at the top, so we need to write grams of calcium cyanide at the bottom. Whatever unit goes here is the unit that goes down at the bottom, okay? And I'm trying to get to moles of ammonia. I'm just going to kind of write this out here because that's where I'm trying to go. Okay, so this means I need to go from grams to moles of calcium cyanide. I go back up to my balanced equation. I have a coefficient of 1 in front of calcium cyanide. And in front of ammonia, it's a 2. Okay, so I'm going to use a 1 to 2 ratio. Okay, so for every 80.11 grams, there's 1 mole of calcium cyanide. And then this is where I use my molar ratio. And again, my coefficient in front of calcium cyanide was 1. So 1 mole of calcium cyanide. My coefficient in front of ammonia is 2. So 2 mole of ammonia. And I got to my final unit, so I'm done. Grams of calcium cyanide cancels, moles of calcium cyanide cancels. Okay, so now I just have to do the math. Okay, so I'm just going to type this all kind of in at once. So 15.6 times 1 times 2, close parentheses, divided by 80.11. Oops. Oh, it's times 1, so it'll be fine. Times 1. And we end up getting 0.389. And I'm just going to round this. Do we see this number? 389. I'm going to round this to 0.39. 0.39 moles of ammonia. Okay. Next question is, how many grams of solid calcium carbonate, CaCO3, can be produced? Okay, so I'm just going to, can start with either this, you can start with this, it really doesn't matter. I'm going to start with the moles of this. Mole of NH3. So mole of NH3, again, goes down here at the bottom. And I'm trying to get to grams of calcium carbonate. Okay, so I need to use my coefficients again. So my coefficient in front of ammonia, again, was 2. So for every 2 moles of ammonia, I have 1 mole of CaCO3. Okay, and again, I'm just getting these from my molar ratio. Okay, so then 1 mole of calcium carbonate, and I look back up to where I did that math, is just up here, and whoops, 100.09 grams of calcium carbonate. So again, I'm just going to multiply everything on top. So 0.39 times 1 times 100.09, close parentheses, divided by open parentheses, 2 times 1, close parentheses. I end up getting 19.52 grams of calcium carbonate. Okay. And then down here at the bottom, so if I have 2 moles of calcium carbonate and 3 moles of water, which reactant is the limiting reactant? Okay, so I'm going to get some loose leaf paper to actually answer this. So as we're thinking about this, if I'm just looking at my molar ratios, calcium cyanide to water, okay, so my coefficient for calcium cyanide in my balanced equation is 1. My coefficient for water is 3. So if I have 2 of these and I have 3 of these, I'm going to be able to react all of my water and not all of my calcium cyanide. So that means that water is a limiting. And then we're going to end up with 1 extra mole of calcium cyanide. Okay, so looking back at the actual questions, what's the limiting reactant? Water. How many moles of ammonia can be produced? So if I have so my ratio from water to ammonia is 3 to 2. And since I have 3 moles of water, that means that I can end up with 2 moles of ammonia, so 2 moles. And how many of calcium carbonate? Again, it's just going to be 1 mole, just because the amount of my limiting reactant is equal to the coefficient for my limiting reactant in this example, so that makes this a little bit easier.